Well, yes, first of all, you have to determine the value of lambda. And you can see that 1 equals the integral from 0 to infinity, right? In fact, minus infinity to infinity, f of u du. And you get the integral from 0 to infinity, lambda the exponential minus u over 100 du. And you get lambda times 100. So lambda is 1 over 100. And then you can find the probability that x is between 50 and 150. So you get the integral from 50 to 150, lambda the exponential minus u over 100 du. Okay, now you can use the calculator to get the answer. So I will skip it. Okay, all right. Now we just finished the first part of the probability mass function and the probability density function. Now I want to discuss a little bit about the cumulative distribution function. Let's start with the following example. Consider the probability distribution for the digital channel example. Then X is the number of bits received in error when you transmit 4 bits. And X could be 0, 1, 2, 3, 4 with the probability 0.65 and so on. And then you can find the probability of 3 or fewer bits in error. So you come up with the probability that X is less than or equal to 3, which is the probability that X equals 0, plus the probability that X equals 1, plus the probability that X equals 2, X equals 3. You sum all numbers here to get 0.9999. Okay, and you can also compute the probability that X equals less than or equal to 2, or 4, or 0, or 1, right? And then the probability that X is less than or equals to u, the number is called the cumulative distribution function of a random variable. Okay. For example, if k is 0, 1, 2, 3, 4, then the probability that X equals k is 0.35, 0.22, 13, and 0, and 10. Okay, so you can find the probability that X is less than or equals to 0, less than or equal to 1, less than or equal to 2, less than or equal to 3, or 4. So you come up with 0.35, 0.57. In order to get 57, you can add the two numbers, right? 35 plus 22 gives you 57. You add the 3 numbers here to get 0.77. You add 4 numbers, you get 0.9, and 5 numbers, you get 1. Okay. If you draw the graph, you can get 5 columns here for 0, 1, 2, 3, 4. And probability that actually is less than or equal to 2 should be the sum of all the all the values, right? Corresponding to the height of the 3 columns here at 0, 1, 2. Okay. What if you have a continuous random variable, not a discrete random variable? Then instead of using, several columns like this, you need to use the a smooth function f(x), and then you have this function, the blue curve, and the capital F of u is the probability that x is less than or equal to u, and that will be the integral from minus infinity to u, and it is the area of the blue region. Okay, you can draw the graph of the cumulative distribution function as the right curve right here. Okay, and the value as you give you the value of the function f of u. We can have a look at the following example. A day's production of 850 parts contains 50 defective parts. 2 parts are selected at random without replacement. And suppose that X is the number of defective parts in the sample. And then you want to find the cumulative distribution function of X. We all knew that the probability that X equals 0 and 1 and 2 could be computed. And we take it for granted that the probability that X equals 0 should be 0.886. The probability that X is 1 is 0.111, and the probability that X is 2 is 0.003. Okay, and then you can come up with this. You can come up with this. The f of x, is the probability that x equals 0, which is 0.886. At 1, you get at 1 you get 0.111, and at 2 you get 0.003. You can find f of 0, which is the probability that x is less than or equal to 0. So you get 0.886. F of 1 is the probability that x is less than or equal to 1. You get 0.997. The probability that x is less than or equal to 2, you get 1, right? And then you can find the probability that x is less than or equals to minus 0.8. X has to be greater than 0. That's why greater than or equal to 0. That's why the first probability equals 0. If you want to find the probability that x is less than or equal to 0.5, then you have only one option, which is the probability that x is 0. So you get 0.886, which is f0. And you can also use similar arguments to get the probability that x is less than or equals to 1.4 and 2.3. Okay. In summary, you get the function f of x, the capital F of x, which is 0 for any x negative, 0.886 for any x between 0 and 1, 0.997 for any x between 1 and 2, and 1 for any x is which is greater than or equals to 2. And if you draw the graph of the function capital F of x, then you get this. X is negative, so you come up with this one. X is between 0 and 1, then 1 and 2, and then 2 is then more than 2. All right. Okay.
Teachers, I have a question.
Yes.
I say that fx is equal to 0.997 when x is larger than 1 and smaller than 2. Yeah, but why on top right here we see that f1 equal to b of x smaller, that x is smaller than 1 and equal to 0.997. So I don't understand why those two had the same value.
Well, what is the probability that x is less than or equal to 2? I mean, between 1 and 2. I mean, less than or equal to 1. What is that? What is this one? What is that? It is the probability that x is 0 plus the probability that x is 1, right?
Yes.
And you want to find the probability that x is less than or equals to 1.7, for example. What is that? It is still x equals 0 plus x is 1, correct?
Oh yeah, sorry. I
Right,
forgot
yeah.
that it is the discrete value.
That's true.
Yeah.
That's true. That's why they are all the same. Okay. Okay, that makes sense. Now, if you want to go, you can go forward, right? You can find the capital F. Can I go backward? Back to that? What do you think? So if I replace this one a little bit, if I replace this one a little bit, then I see that the probability that x is less than 2, what is that? Then you get the probability that x is 0 plus the probability that x is 1. Am I right? Do you understand? How about the probability that x is less than or equal to 2? Then you get the probability that x equals 0 plus x is 1 plus x is 2. Okay? So if you compute the difference between them, like x is less than or equal to 2 minus the probability that x is less than 2, then you come up the probability that x equals 2. Do you understand? Is it okay? The first part is f of 2, right? And the second part, what is that? The second part is simply the left limit of the f of f of u when u goes to 2 minus. And denote this one by the f of 2 minus. Okay. Do you understand? So what I can say is that probability that x equals 2 is f of 2 minus f2 minus. So f of 2, the probability that x equals 2 right here is simply the germ that you can observe at the point 2, right? So if the function jump from f2 minus to f of 2, then you get the then you can get the probability that x equals 2. Back to our problem, the first term is 1, the second term is 0.997, therefore the difference is 0.003. And I can conclude that the probability that x equals 2 should be 0.003, and this is correct. Okay, you can also have a look at the germ at the point 1. At the point 1, you get 0.997 minus 0.886, and that is 0.111. And it is simply the probability that x equals 1. And that is true. That is true, right? And you can use similar arguments at the points x equals 0 to get the probability that x equals 0, 0.886. Okay? Is it okay? That's all clear.
Yes, sir.
Okay. Now I want to move to the next example, in which you want to deal with the continuous random variable. Consider the current method in a thin copper wire. Recall that the range of x is 4.9 to 5.1, and the function f is 5. Then you want to find the cumulative distribution function. Okay, if x is less than 4.9, you have nothing to compute. It is 0. That is very trivial. If x is between 4.9 and 5.1, what do you get? You come up with this region, right? And what is the area of that one? You have 5 for this, and you have x minus 4.9 for this. Okay, then the area becomes 5 times x minus 4.9. All right, is that okay? And then you get the you get this one. X is more than, for any x more than 5.1. The area of the whole rectangle is 1. So you get the function capital F. And if you draw the graph of the capital F, you get this one, right? You get this function. And this is the cumulative distribution function of the random variable x. Okay, is that all clear? Okay. Now, if you want to find, so it is very easy to get the capital F from relative to F. Can I go back to that? You can always go back to relative F by differentiating the capital F. Why is that? The reason is that the capital F of x is the integral from minus infinity to x of the function f t dt. So if you want to go back to relative F, you may want to remember the fundamental theorem of calculus, which states that f prime is equal to f of x. Okay, and then you get this one. All right. So if suppose that the capital F is here, and you differentiate the function for any x less than 4.9, it is 0. For any x more than 5.1, it is 0 as well. For x between 4.9 and 5.1, you can differentiate it to get 5. That's why you get the density function 5 for the relative density function. Is it okay? Oh, okay. You want me to slow down a little bit? That's fine. Please let me know if you want me to slow down a little bit. That's fine. Please let me know. Okay. Um. Okay. Now, you can see that you can find the probability that x is less than or equal to u. That is f of u. And you can also see that the probability that x is less than u is f of u minus the left limit. And then from these two equations, you can find the probability that x is equal to u. And then it is the difference between them, and you get f of u minus f of u minus. And from these two, all these three equations, you can find the probability that x is between a and b, greater than a and less than or equal to b. So you get the probability that x is less than or equal to b minus the probability that x is less than or equal to a. And the first term is f of b. The second term, you get f of a. Do you understand? Okay, that makes sense. All right.
Yes, sir.
If you want to find the probability that x is between a and b, including a and b, then you should use this one. You have the probability that x is less than or equal to b minus the probability that x is less than a, and then you get the probability f of b minus f of a minus. Okay, so in this case, it's f of a minus. um, these two terms are different. If they are different, if f is not a continuous function, if f is a continuous function, then they are the same. Okay, if you know the capital F, you can find the probability. If the capital F is given, you can also find the little f by looking at the difference between the fu and fu minus. If x has a discrete distribution, if x has a continuous distribution, then you can find little f by computing the derivative of the capital F. So you get this equation, you have this one, okay? Let's consider this example. Please find the probability that x is less than or equal to 0, probability that x is less than 0, probability that x equals 0, and then the probability that x is less than or equals to minus 0.5. Can you do it? What do you get with it? Hello, can you hear me? Better?
Yes, sir.
Okay, great. So you can see that this probability is f of 0, and that is 1. Okay. For the probability that x is less than 0, it is f 0 minus, and you get 0.5, right? The last limit at 0. And then the probability that x equals 0 should be the sum at that point, at the point 0, and you get 1 minus 0.5, and you get 0.5. Okay. Now, how about the probability that x is less than or equals to minus 0.5? It should be f of minus 0.5, right? So it is this point, and you come up with that, and this is 0.25. Okay, so the probability is 0.25. Understand? If you want to find the probability that x is equal to minus 0.5, and then it is simply 0. Okay, because the function is continuous at this point. So you have no jump, it means that the jump is 0. Okay, is that a question so far? Is that all clear?
Hello. Hello.
Yes.
Teacher.
Mm-hmm.
For the probability at x equals to 0, why don't we use the formula fu minus fu minus?
Which one?
Let me show you. Let me share the screen for you to see.
Yes, of course.
Why don't we use this formula? Can you see it?
Well, you can. You can always use that. You can always use that.
So when I use this formula, the probability will become 0 because f0 is 1/2.
Okay.
And
all right. I will show you. So what is f of 0? The probability that x equals 0. It is the f0, right? Minus f0 minus, correct? That is what I did. What is f0? What is this one?
It's 1/2.
F0 is not 1/2. Can you see the empty circle right here? It means that the function at 0, f of 0 is 1. F of 0 is here.
Oh,
and the left limit is here.
Oh, I didn't see it clearly.
Can you see it better? Can you see it better now?
Yeah, yes.
Yep. So the function, you have an empty circle right here. That's why the left limit is 0.5, and the function at the point 0 is 1. And then you come up with the difference, 1 minus 0.5, and you get 0.5. Okay. That's better.
Yes, I understand it now. Thank you,
Okay,
sir.
sure. Now I want to talk about the next part, the expectation. And I want to start. I will start on this part with an example. Suppose that there are 20 numbers with the values 1, 2, 9, 4, 3, 3. So you get 20 numbers randomly from a set of 10 values. Then you can find the average value, which is 1/20 times 2 plus 9 plus 4 plus 3 plus 3. All right, the sum. And then you can rewrite expression as follows. You get 1 over 20 times 1 times 2 plus 2 times 1 plus 3 times 3 and so on. And you get 1 times 2 over 20 plus 2 times 1 over 20 plus 3 times 3 over 20 and so on. And if and now you can see that 2 over 20 is the relative frequency of number 1 in the sample. There are two number 2, okay? I'm sorry, 2 number 1, 2 number 1, okay? And then you can for number 2 you can find 1 number 2 right here, and for number 3 you can find 3 number 3, right? 3 number 3, 1, 2, 3, okay? So there are 3 number 3, and the relative frequency is 3 over 20 for number 3, and you can keep doing that. If I denote by f of k the relative frequency of the number k in the sample, then you can get the sum. You can get the sum k times f of k. All right, and this sum is has the same values as the H bar, and then you call it the expectation of x. Is there any questions? Okay, that should be okay, right? Then we get the following definition for the expectation. The expectation of a random variable x is the sum u f of u, or that is for discrete random variable. For a continuous random variable, then you get the integral from minus infinity to infinity u f of u du. Okay. Okay. Let's consider. Oh, by the way, there are many names for the expectation. You can call it the expected value, the mean value, or the average value. Okay, now suppose that the average score of all the students is 4. Okay, and then I double the score of each person. Then what is the new average value? It should be 8, right? And you get 2 times the mean of x, basically. And then if I add 1 point to it of the new score, I will get this, and the average score will be 9, and it is simply the 2 times the mean value of x plus 1. Then in general, the mean value of ax plus b is 8 times the mean of x plus b. So you get this one. You see that the mean of ax plus b is 8 times the mean of x plus b, and the mean of x plus y is the mean of x plus the mean of y. Okay. Let's consider the following example. Do you know how to get that? The net gain is what is actually what you gain, what you can win. It doesn't matter if you have only one game, but if you play many games, then the net gain is the total amount of money that you can win. First of all, you need to get the model. X could be 1 or -1 with the probability 18 over 38 for the first for winning and 20 over 38 for losing. Correct? Do you agree? Right, we have 38 numbers in total.
Sorry, sir.
Mhm.
Why we have 28 or -1 when we lose?
Yes, as one of your friends mentioned, you have 0 and double 0. 1 through 36, you have 36 numbers, 0 and double zeros, then you get 38 options in total. Is it
Oh,
clear?
yes.
Okay, you see
Yes,
that is 0 right here, and double 0 is somewhere. Okay, so you can find the mean value of x, where x is what you can win. Then it is 1 times 18 over 38 plus -1 times 20 over 38, and then you get -1 over 19. That makes sense? Now suppose that y is your net gain in 10 games. Then x1 is what you can win in the first game. X2 is what you can win in the second game. X3 is what you can win in the third game, and then and so on. X10 is what you can win in the last game. Then your net gain will be x1 plus x2 plus x3 plus x10, right? And then you want to find the average next gain. So you get the mean value of y, which is the mean of x1 plus the mean of x10. And the average value of each one is going to be simply -1 over 19 plus -1 over 19. So you get -10 over 19. Is it okay? How about the next example? If this is the example we have, then you get then the PMF, the probability mass function of the amount of memory X in a purchased flash drive satisfies the following table. You want to calculate the average amount of memory in the flash drive, so you want to find the mean value of X, and that would be 1 times 0.05 plus 2 times 0.1 plus 4 times 0.35 plus 8 times 0.4 plus 16 times 0.1. Okay? Do you understand? That makes sense. And then you can get the answer. So I will skip it. I think it's quite easy for you.
Teacher, can I ask the previous example?
Yes?
So in the previous example, you said that net gain is the total amount of money that you win over one game, right?
In one game. The net game, yeah, actually is for one game.
So why does after we play 10 games, the amount of money we have is minus 10 over 19? Because I thought it has to be in a range of like 0 to 10.
What do you mean by 0 to 10?
It means that it's not an odd number, right? It's like
no, wait a minute. It doesn't matter if you have odd or even. Like X is for a single game. Understand? X is your net gain in one game. Do you understand? So
yes.
the average net gain should be the average value of X. This is A. This is question B. Then you have A, and this is B. Do you understand? Then the mean value of X is 1 times 8 is minus 1 over 19. That is for a single game. Now you want to find the net gain if you play 10 games. For 10 games, then you have many games, right? And in each game, you can win or lose $1. Suppose that X1 is what you can win in the first game. X2 is what you can win in the second game. X3 is what you can win in the third game, and so on. Then, and Y is what you can win in all games. So after you play 10 games, how much that you can win? How much do you win? That is Y. Then Y is the sum. Understand? Do you understand it? Is that clear? Is that clear? Hello? Is that all
yes,
clear?
it's clear.
Okay.
Yes.
Then the mean of Y is the mean of the sum. And as I said, the mean of the sum is the sum of the means. Then you get the mean of X1 plus the mean of X2 and so on. And the mean of each one is the mean, the average amount of money that you can win in each game. That is the mean of X. That's why you get minus 1 over 19. Okay? So each average value is 1 minus 1 over 19. And then you can find this the expression, the value of the expression, and you get minus 10 over 19. Do you understand that? No, this is not true if you always lose money, but on average, you will lose a lot of money. I'm not saying that you always lose money. Sometimes you can win, but on average, if you the more you play, the more you lose. So you can say that if you play one game, then you lose 1 over 19 dollar, right, on average, and you lose $1 every 90 games. No, if you choose even, you don't win. Double zero, I don't think double zero is anything that above 0 is an even number. You know, the point is that if I already said, the more you play, the more you lose. Well, let's say, suppose that you play several games. Okay, like over 10 divided by 10. This one can be approximated by is equals to the average value of x, which is -1 over 19. Okay, x1 over 1 could be different from -1 over 19 because you can win $1. x1 plus x2 divided by 2 could be different from -1 over 19. Could be. Okay. However, we can prove that x1 plus xn all divided by n, this will be close to -1 over 19 when n goes to infinity. This was proved, and that is called the law of large number. Okay. So if you play many games, it means that n is large enough, then for sure you will lose. Okay. Is that clear? But if you play one game or two games or three games, you may win those games. All right. But if you play many games, then on average you will lose. Okay. Let's consider this example. Suppose that actually the amount of time a book onto our reserve is actually checked out. Find the mean value if the cumulative distribution function is 0, if x is negative, x squared over 4 if x is between 0 and 2, and 1 if x is greater than or equal to 2. Okay, do that. Okay, how can you get the answer? In this case, you have the capital F. Remember, that is the capital F, not the little f. And for the definition of the mean value, you have to use the little f, which is the density function. Therefore, I need to find the density function first. When x is negative, it is 0. When x is between 0 and 2, it is x over 2. When x is more than 2, it is 1. It is 0, I mean. Okay. So the mean value of x is the integral from 0 to 2, x times x over 2 dx, and you get x to the third over 6, right? From 0 to 2, and you get 8 over 6, or let's say 4 over 3. Is that clear? Is it okay?
Can you repeat again about the equation Ax, sir?
Okay. The mean of x is the integral from minus infinity to infinity, x times f of x, correct? All right. And
Yes.
the function is 0 outside the interval 0, 2. That's why I only need to integrate from 0 to 2. Okay. And within the interval 0, 2, the value of the function f of x is x over 2. Okay. And then you get the integral of x squared over 2. And then you get x to the third over 6 from 0 to 2. And the answer is 4 over 3. Do you understand?
Thank you, sir.
Okay. All right. Now, what if I want to find the mean value of x squared? If I want to find the mean value of x squared, then I should get x squared. You get 1 squared, 2 squared, 4 squared, 8 squared, 16 squared. Okay. Then you can see that the mean value of x squared is 1 squared times this, because the probability mass function isn't changed. You get 2 squared, 4 squared, 8 squared, 16 squared. Okay. So it seems that if you get like, where is that? If you have the x squared here, then it's just simply you want to find the sum of u squared f of u. Okay. And then you get the following formula for the mean value of x squared. Okay. In general, if you have like the x to the third, then you should have the x to the third. If you have x to the fourth, then it should be x to the fourth. If you have the exponential of x, then you should have the exponential of u right here. Okay. So in general, this is what you have for the mean value of g of x. It is the sum GUFU for discrete random variable. It is also the integral GUFU for continuous distributions. Suppose that X is the current measured in milliampere with the density function 0.05. What is the effective value of power when the resistance is 100? For 1,000 over 3. Well, this is what you can do. The expected power. What is the power? The power is R times I squared, and I is the current measured in ampere, and that is 10 minus 3 times x, right? Then this becomes R times 10 minus 6 times I squared, right? And you get 10 minus 4 because R is 100 times I squared. Then the expected power is this expected value of 10 minus 4 times I squared. Then 10 minus 4 times the mean value of I squared. And that is 10 minus 4 times the integral from 0 to 20. And then U times 0.05 du. Okay? Is there any questions?
Teacher, I think it must be U power 2, right?
Let me see. Yeah, it should be U square. Thank you. It should be U square. Okay. Is that clear? Let's consider this example. Okay, so the expected cost is the mean of u to the of x to the third, right? X to the third, and that is the integral from 0 to 1 u to the third times 1 du, right? And you get u to the fourth over 4 from 0 to 1, and you get 1/4. Is that clear? Okay.
Yes, sir.
All right. Now I want to talk about the median. Okay, so what is the mean? The mean is the average of values. Suppose that you have 5 values, 1, 2, 5, 8, 10. You compare the average value, which is 5 over 2, 5.2. If you have an error, let's say instead of 10, you get 100, then the mean value is 23.2. The two numbers are completely different. Okay. Now we have a problem here. It is very easy to get a typo like this. This value 100 is a strange value, right? And how can you get the center uh, uh, that is not heavily affected by influenced by these strange values? Then we can come up with the average position. I arrange the numbers in increasing orders. Let's say 1, 2, 5, 8, 10. Then I get the number in the middle. I get 5 here. So 5 is called the median is the median of the observations. All right. If I have 5 numbers, 1, 2, 5, 8, 100, then the median is still the same, 5, right? So these two numbers, the strange values, 100 does not have any influence on the median. Okay. In this case, there are 5 numbers, and you can find exactly one value at the middle. What if you have 2 values? Like there are 4 numbers here, and there are 2 numbers in the middle, 2 and 5. Then you need to use the average value 3.5 for the to get the median of the observations. Do you understand? So the median is simply the point that divide the whole populations into two equal parts like this one. You have 50% and 50%. Is that okay? Is it okay, you guys? That process? Is it all right? Good.
Sir.
Yes.
So the median number is the number that we will divide the number of the amount of number to two part, right?
Mm-hmm. Yeah, you can think about it that way.
Yes, thank you.
All right. So here is the formal definition of the median. the median of a random variable x are all points m such that the probability that x is less than or equal to m greater than or equal to 0.5, and the probability that x is greater than or equal to m is greater than 0.5. Okay. Okay. And then you can see that on the left-hand side of this inequality is simply f of m. So you can rewrite this, the first inequality, as follows: f of m is greater than 0.5. The second inequality, what do you get? This implies that the probability that x is less than m, you subtract like f of m is 1 minus the probability that x is greater than I'm sorry, it should be greater than or equal to m. That should be less than or equals to 1 minus 0.5, and you get 0.5. So you come up with this equation. So you have these two equations, right? These two inequalities. All right. If, in particular, if x is a continuous random variable, then the capital M f of x is a continuous function. It means that f of m and f of m negative are the same. So f of m is greater than or equals to 0.5, and f of m is also less than or equal to 0.5. And then you come up with this equation. M is the solution of the equation f of m equals 0.5. Okay? Do you understand? Is it okay?
Teacher, your microphone is mute.
Oh, I'm sorry. So you see that we draw a line at passing the point 0.5 right here. Then you can see that f of 0 is that point, right? Is greater than 0.5, right? And f of 0 minus is 0. Okay, so we can conclude that the median of x is basically 0. Okay. For the second example, you can see that you have a continuous function, and at the point 5, f of 5 is 0.5. Okay, and then you come up with I can conclude that the median is 5. Okay, that makes sense. Okay, let's consider the following example. The PMF of the amount of memory X in a purchase flash drive satisfies the following table. Find the median of the random variable X. Can you find it? 4. Okay, you may say the probability that x is less than or equal to 4 is simply, what is that, 0.05, 0.1, 0.35, and you get 0.5. And then I can also consider the probability that x is greater than or equal to 4. That would be 0.5, 0.85. So yes, you can say that the median of x is 4, right? Besides, I can also say that the probability that x is less than or equal to 8, what do you get? You get, let me see, 0.45, 0.9, right? And for this, you get the probability that x is greater than or equal to 8. That would be 0.5, right? So I can conclude that the median is also 8. Okay. Besides, I consider 7. May I consider 7? What is the probability that x is the probability that x is less than or equal to 7? I get 0.5, right? Okay. And the probability that x is greater than or equal to 7, it is still 0.5. All right. So I can say that the median is also 7. It means that the median of x is any number between the interval 4 and 8. Do you understand? Do you understand? Okay. Now I want to find the median of a random variable given the cumulative distribution function. So in order to find the median, you need to solve the equation f of x equals 0 equals 1/2. It means that x squared over 4 is 1/2, and you can say that x is the square root of 2. Okay. So the median is the square root of 2. So as you may see it, the mean is less than the median. The mean is if the mean and if the distribution is negatively skewed, then the mean is less than the median. If the distribution is symmetric, then the mean and the median are the same. If the distribution is positively skewed, then the mean is greater than the median. It means that the mean value is closer to the outliers, all right, and the mean could be heavily influenced by the outliers, the strange values. Okay, do you understand? All right. Okay, so back to the notation the one I mentioned over here. I already mentioned the cumulative distribution function, the discrete distribution, probability mass function, probability density function. I already talked about the mean and the median, which I used to describe the center Now I want to talk about the last one, the variance and the standard deviations. Okay, I will skip the interquartile range in this chapter. So now I want to talk about the variance. Why do we need to talk about that? For now, we know the distribution, and then we can get the center, right? Which could be the mean value or the median. Let's consider the following example. Suppose that we have you consider the scores of two classes. In the first class, all the scores are 5, 8, 5, 6, 8, 7, 8 with the same relative frequencies. All right. And then in the second class, the scores are 3, 4, 5, 6, 7, 8, 9, 10 with the same relative frequencies, 12.5%. The two distributions had the same mean values. Okay, they are 6.5. The average values are the same. Okay, so you see that the centers they are at the same locations center. However, the two distributions are completely different, right? In the first class, you will always pass the class, okay? But in the second class, you can fail. However, in the second class, you have a chance to get very high score, 9, 10. In the first class, you don't. Okay, so you see that the two distributions are completely different. Okay, therefore the mean values are not enough. You want to find a way to describe the variation, and that would be the variance of X. Okay, let's consider the following example. Okay, now suppose that we have 4 observations. Suppose that there are 4 observations, which are 1, 2, 5, 8, and then you compute the average value, which is 4, and then you have 4 values, 1, 2, 5, 8, and then you compute. You can find the mean value, which is 4, and then you compute the deviations: 1 minus 4, 2 minus 4, 5 minus 4, and 8 minus 4. Okay. If all these values are close to 0, then the observations are close to 4, the mean value. Otherwise, they are far from the mean value. Then I can find the sum of squares: minus 3 square, minus and then 1 square, and then minus 2 square, and then 1 square, and then 4 square. And then you divide the sum by 4, and later you divide not 4 but 4 minus 1. You divide by the degree of freedom. You should get this one, and this is called the average value of the square of the deviations, and you call it the variance. Okay. Here's the formula for the sample variance. The sum you get the average value of the square of the deviations, and in order to find the average value, you divide the sum by the degree of freedom instead of the number of observations to get an unbiased estimator. So here is the formal definitions for the variance. The formal definition for the variance is the mean value of X minus mu squared, where mu is the mean value of X. Okay. If X is a discrete random variable, then the variance is u minus mu squared times f of u. If x is a continuous random variable, then it is simply the integral from minus infinity to infinity u minus mu squared f of u. Okay? Do you understand? Is it all clear? Is it okay?
Yes, sir.
Okay, so the variance has the doesn't have the same units as the mean value does. For example, if x is in dollar, then the mean of x has the units dollar as well, but the variance of x has the units dollar square. So you want to find something with the same unit, and you can come up with the standard deviation, which is the square root of the variance of x. Okay. Let's consider the following example. There is a chance that a bit transmitted through a digital transmission channel is received in error. X is the number of bits received in error of the next 4 transmitted bits. The probabilities are given below. Calculate the mean and the variance. Okay, suppose that you have 2 columns here. You get x could be 0, 1, 2, 3, 4, the values, and the probabilities, the times 0.6561, 0.2916, 0.0486, 0.036, and 0.001. The sum of all these numbers is 1, definitely. Then you can multiply these 2 columns to get 0, 0.2916, 0.0972, and so on. And you have 5 values. If you compute the sum of these 5 values, you get 0.4. What is 0.4? 0.4 is simply the mean value of x, because it is the sum of x, f of x. Is it okay? Now you can multiply, then you can compute that the square of the derivations of the values around the mean value. So you get x minus 0.4 square, 0.00 minus 0.4 square, 1 minus 0.4 square, 2 minus 0.4 square, and so on. And you come up with all numbers here. And then you multiply this column by f of x to get this column, right? And then you find the sum of all the values in this column to get 0.36. Do you understand? And 0.36 is the variance of x. Do you understand that? Is it okay?
Can you repeat one more time, sir?
Oh, okay. Maybe I'm going to use OneNote to explain it. So you see that 0.4 is the sum f of x, and this is the mean of x, correct?
Yes.
Is that correct? Okay. And how about 0.36? It is the sum x minus 0.4 square f of x. Understand?
Yes.
Okay. And this is the variance of x. If the variance of x is big, the variation is big. If the variance of x is small, the variance is small. Okay?
Yes, I see it.
Okay. All right. Now suppose that there are 4 observations, 1, 2, 5, 8, and you find the mean value 4. You have this one, right? Quite similar. If I consider x plus 1, then I come up with 2, 3, 6, 9, and the mean value becomes 5. And when you compute the derivations, you see that they are the same, right? You have the same derivations. It means that the variance of x plus 1 is the same as the variance of x. Okay, so in general, x plus b, you get the same variance of x. Okay. All right. Okay. And you can also prove that the variance of ax is a squared times the variance of x. Then you can conclude that the variance of ax plus b is simply a squared times the variance of x. For example, if you get the variance of 3x minus 4, then you get the variance of 3x, and that is 9 times the variance of x. While the mean value of 3x minus 4 is 3 times the mean of x minus 4. Do you understand? You understand that? Okay. All right. I think that's enough for today. Let's stop here and see you next time.